Greetings and welcome. This is a video for Mr. Waddy's Math 4 class, and this is going to cover equations and applications of sine waves, and we're going to, in this section, be looking at simple trigonometric equations. So that will be our title, Simple Trigonometric Equations. And while I'm doing this, I just want to encourage you that at any point throughout this video, hopefully you are watching with a partner or by yourself on a laptop, and you'll be able to pause at any given time. So if you're working on the homework or on classwork problems, hopefully you'll be able to stop and make sure, for one, when you're taking notes, have everything written down, as well as be able to go back and use it as a reference when doing those other problems. So we're going to start by looking at an equation. If I wanted to solve the equation sine of x equals 0.5, and we're going to be considering the fact that if I was to graph this equation, let's see. Recall that the domain of sine goes from negative infinity to infinity. And let's see, if this is pi over 2, this would be pi over 4. This would be pi over here. This would be 3 pi over 4. And sine follows this following pattern, where sine of 0 is 0. Sine of pi over 2 would be up at 1. All right, if we label this as 1. And we actually have this curve somewhat like this. And then it comes back down to 0 when it reaches pi. And over here at 2 pi. And at this point here, it's at negative 1. And we have a sine wave that looks something like this. And this wave does in fact repeat infinitely in both directions. So when I ask the question, when is sine x equal to 0.5, there are actually infinitely many solutions to this. It would hit again over here and infinitely. But I'm interested in two primary solutions, which is going to be within one full cycle of sine, which is said to be the period, which goes, which is 2 pi, right, or 360 degrees. Sine goes through one full cycle, and then it starts repeating itself again. All right, so I'm interested in the solutions that occur within that one period. All right, and sine appears to be 0.5 at two particular points, right here and right here. And this point here happens to be 5 pi over 6. The way we could calculate that is using our hand trick, which if I try to figure out when is sine equal to a half, sine are the fingers to the left, cosine are the fingers to the right, and if I happen to put down this finger right here, I'd get the square root of 1 over 2, and I would have sine being 1/2 at this finger. This finger represents the 30-degree angle, or pi over 6. So I expect that x must equal 5, jumping ahead of myself, must equal pi over 6. The other time that sine is going to be at 0.5 is over here, in which for my second quadrant, alright, so this is my first quadrant occurring here between 0 and pi over 2. My second quadrant occurs between pi over 2 and pi. And the reference angle is still going to be pi over 6, but this remaining angle here is going to be pi minus that 5 pi over 6. Minus that pi over 6. Which is in fact going to give us the 5 pi over 6 when I find a common denominator. I'll get x equals 6 pi over 6 minus 1 pi over 6, or x equals 5 pi over 6. So these are my two significant solutions, the ones that occur within the period of from 0 to 2 pi, that one full cycle there. Now, if I wanted to consider the other possible angles, right, when it's going to hit this, for instance, or when this wave comes back around and it's going to hit twice up there, and it keeps going in every direction, I would be interested in the coterminal angles of these reference angles here. So considering this angle, I would have x equals pi over 6, and to find a coterminal angle, alright, to go from here over to here, it is 2 pi units away, right? And remember when we were thinking about the unit circle, a coterminal angle was just an angle that would land back in the same position on the unit circle, no matter how many times we happen to spin around that circle. So I can add multiples of 2 pi to pi over 6. Right, so that would give me one reference angle, but if I want to consider all of them, I'm going to have this value of n, where n just represents the number of times we're going around the circle. Right, and that actually even works if n is negative, then I would be subtracting 2 pi, and I would be landing in some of the negative coterminal angles. Alright, so this represents half of all of the solutions when sine x is 0.5. The other half would be the coterminal angles for 5 pi over 6. So x equals 5 pi over 6. And once again, in order to find the coterminal angles, I would add 2 pi any number of times that I want and get something like 2 pi n, right? So if I want 3 times around the circle, I would add a total of 6 pi to that value. And this would be, right, all possible solutions are represented within these two equations, for n being any integer. Alright, so that is a more basic solution in which we happen to know the value of sine at that particular point for that particular ratio in which we were using the sine hand trick. But in the next example, we're going to be looking at situations when we don't necessarily know the ratio off the top of our head, and we'd have to either use a table or a calculator, and more specifically, we'll be using inverse functions. So I'll see you next example.